Hi, it's Chili here, and welcome back to the beginner game programming tutorial, lesson 3. In the last lesson, I got you guys to move our targeting reticle. So hopefully you've got something like this now. It should have moved from here to here. And I'll show you the whole window. That's what it is. And the reason why it moved is because you changed all of these numbers here, the x and y coordinates specified in the putPixel functions. Now, the one thing that I wanted you to gain from this experience is I wanted you to gain the realization that this is a really slow way of going about things. It's a real pain in the ass to modify all of the x and y coordinate numbers for these putPixel calls. And this is a very simple graphic. Imagine a sprite with hundreds or even thousands of pixels. That's just, it's quite untenable. So now I'm going to show you the easier way. There must be an easier way, and there is. But first, what we have to do is we have to delete these 6 lines here. And deleting these lines, what do you think it will do? The answer is it will get rid of the horizontal wings of our targeting reticle. Now there's a reason why I'm doing that, and I'll come to that later. But first, I'm going to type some code. Alright, int x equals we'll say 700. It's a good start. Copy that. And now I'm going to replace all of the x parameters here with x, the letter x. Okay. Now I want you to make a prediction about what I did here and how it will affect the program. Are you done making your prediction? Let's see if your prediction was correct. So, as far as the effect on our output, no effect. It is exactly the same, right? So, what is the meaning of all this? Well, let's see what happens if I change this 700 to a 200. What do you think will happen? Oh, our vertical line here has moved a considerable distance to the left. Alright. So the answer is that now by changing this one number here, I can change the horizontal positioning of our graphic. Instead of having to change every single freaking number here, I created what we call a variable here, and I use that variable in all the function calls. And by changing the value assigned to that variable, I can change the value used in every function call that contains that variable. It's like a programming lever here. A small motion here causes a larger motion to occur down here. All right. So that's the gist of what I've just done here. I hope you could have gained, basically made that prediction just by looking at what I've written. It's kind of straightforward if you think about it. Now I'm going to go into a little bit more detail about what I've done. Alright, so this line here, well, first of all, this x thing, as I mentioned, it's a variable. And what this line here says is I want you to create for me a variable. The type of the variable is an integer. So I want you to make me an integer variable, and it will be called x. So to make a variable, you put a type, you give it a name, and like any other statement, you put a semicolon at the end. So this creates our variable. In actuality, what's really happening, although it's not important, it's more like we're telling the compiler or the computer, however you want to think of it. We're telling the computer to set aside for us a little space in memory. I want you to mark out a space in memory for us. The space has to be the size of an integer. And from now on, we are going to call that little space in memory, we're going to call it x. So from this point on, whenever I say x, I mean that space in memory that you just set up for us. So x is a variable, but it's actually, it's a name, it's a convenient name for a programmer to refer to a spot in memory. Yeah, or a spot in RAM, if you will. So that's what this line here does. Now the second line here, you could read it as x equals 200, but it's not x equals 200 in an algebraic sense. That's not quite it. What's actually happening here is we're telling the computer to put the value 200 into our variable x, or to set the value stored in that memory location to 200. So create a variable x, set its value to 200, and then we're just going to call some put pixel functions. We're going to put some pixels on the screen, and we're going to use our variable x for the x coordinate value, the parameter. So what this does is when the computer sees this, I'm speaking metaphorically, but when the computer sees this, it will first go to the memory location x and retrieve the value stored there, and then it will call putPixel with our retrieved x value plus all of the other specified parameters. Alright, so that's a fairly accurate, I've used metaphors some places, but that's a fairly accurate description of what's actually going on. Now, one thing, one misconception you might have is, if you remember, let's see here, oh, that's not right. Stop it! Okay, if you remember from when I was talking about IntelliSense, you can see that for our putPixel function, the parameters, they all have names here, right? And the name of the x coordinate parameter is x, funny enough. And so you may have the misconception that we have to name our variable x if we're going to use it here. And that is not true. It does not matter what you name your variable. Just to prove that, I'm going to name my variable pubes, int pubes. So I'm gonna, as long as I'm consistent here and I change all the references from x to pubes, my program should compile fine, and it should give us the same output as when it was called x. So it does not matter what you name your variable. The computer doesn't care, but it does matter for other programmers. If you give your variables stupid names like pubes or arbitrary names like A, B, C, D, E, F, it's going to be harder later on to understand what the hell they all represent, especially when you've got like 10,000 lines of code in one source file. So x is a pretty descriptive variable in this case. I mean, you could go overboard and call your variable x coordinate of pixel to be put on, on screen, but that's just stupid. So I think in this case a simple x does the job just fine. Pubes would not be recommended. Alright, so yeah, a rose by any other name would smell as sweet, unless it was called stinkweed. What else? Alright, so you may have wondered just before why I deleted the wings off of our reticle. And now looking at the code, I think that becomes clear. Obviously, if you have elements of your graphic that are extending in the horizontal directions, the x coordinates of those pixels will be different. So we couldn't represent the whole image by just one variable here. All the x coordinates would have to have different numbers. So that presents a little bit of a problem here, because as things stand, we are restricted to graphics that consist of a vertical line, or only in the vertical plane, or however you want to describe that situation. So that's quite a big restriction on a game right there. I mean, I suppose you could maybe manage a game of Pong with that restriction, but it kind of ties your hands up. The answer is, of course, that there is a way to get around that problem, and I'm going to describe it now. But first, let me just undo all of the crap I did here. Undo. There we go. So we're back with what we started. I'm going to create my variable again, int x, and actually, I'm going to call it int dx this time. And we'll say dx equals, we'll say 0. Alright. And now, here's where the magic happens. I'm going to take this this text here. I'm going to copy it to all of the x parameters of our put pixel. So, start debugging. Alright, so we've got our targeting reticle back in its custom position from the beginning of this lesson. Nothing seems to have changed. Unless, of course, we change the value of dx. Let's say it's 50 now. Now we can see our targeting reticle has moved closer to the right hand side of the screen. Likewise, we could give it a negative value. You can do that. Integers can assume negative or positive values or 0. So we will give our dx variable a negative value. And now we see our targeting reticle has moved to the left of the screen. Alright. So this is how we can preserve the horizontal components of our image, our graphic, and still you leverage the variable to affect a large scale change with just one small change up here. Yeah. So I mean, I haven't shown this yet, but obviously the plus sign here means add these two numbers together. And this thing here would be called an expression in C++. Everything is an expression, but here we have an expression within a function call, and you can do that. And what will happen in this case is when the computer gets to this line here, first it will retrieve the value stored in dx, and then it will add that value to 700, and then it will pass that value along with these other values to put pixel as parameters. So yeah, you can do that. You can add numbers to other numbers. You can add variables to numbers, and you can do that inside of the function call if you like. Yeah. So this makes our life a hell of a lot easier now, especially if you were to do the same thing for the y coordinate. And that is what I'm going to get you to do as an assignment. Just as I have variabilized the x-coordinate, I want you to variablate the y-coordinate here. And yeah, that's your assignment. And when we come back, we will learn new stuff. But today, yeah, we learned how to make variables. And I think it's a pretty big step in that it's the first time we've actually created something new in our code here. Before, we were just using a pre-existing graphics object and calling putPixel, but now we've created our own variable. We've made something completely new. So congratulations on that. And I want you to apply that skill to the y-coordinate now. And when we come back, we will learn new stuff.
Game over, yeah!